Traversal refers to accessing each and every node of the tree once and in a systematic order. So for a binary tree, the traversals can be of two types, depth first and breadth first. In the depth first traversals, we have the pre-order, in-order and post-order traversals, which we have done in an earlier video. So in this video, we are going to look at the breadth first traversals, and they are also referred to as level order traversal. So level order traversals are breadth first. Here all the nodes at a given level, they will be accessed before going to the next level. So if we start from the root node, which is at level 0, so all nodes at level 0, right now we know that at level 0 there will be only the root node, it will be accessed. Then the next level will be accessed and all nodes on level 1 will be accessed. So B and C would be visited. Then we go to the next level, level 2. So nodes D, E, F and G will be visited, and then we will go to level 3, nodes H, I and J will be visited. So this is why it is called breadth first, because we are visiting the breadth of a tree before going deeper down. So for level order traversal, we are going to take the help of a queue, which we know is a FIFO data structure. That means first in, first out. So the first thing that needs to be done is to enqueue the root. So this is the root node over here. So we will enqueue and we will take the help of either the pointers, or you can use the data, but the pointers referring to each node is through its pointers only. So we will enqueue the root. So 200 would be put on over here in the queue. The front pointer and the rear pointer of the queue will both point to this element. Now till the time the queue is not empty, we will begin this loop and keep executing these statements. So first statement is dequeue and print data. So dequeue would be always from the front. So this 200 would be dequeued, and whatever was the data at that particular node, so A would be printed out. Now the queue is currently empty, but we have to now perform the second. We are already within the loop, so we have to now execute the second statement, which says enqueue the left child. So the current node is this 200. So we will enqueue its left child, which is node at address 150. So 150, and the right child, enqueue the right child, which is the node at address 300. So this pointer 300 would be put in the queue. Always note that enqueuing will be from the rear end always, and dequeuing will be always from the front end of the queue. Now we go back to the loop over here, check the condition, the queue is not empty, so we dequeue. So now 150 is out and we will print its data. So B is printed. Now the next statement is enqueue left child. So which is the current node? The current node is 150 over here. Its left child is this node D at 280. So 150 has been dequeued, but its left child, which is at node 280, and its right child, which is at address 400, they will be put in the queue. So now we go back to the condition checking over here and see whether the queue is empty or not. No, it is not empty. So again we are going to dequeue. So again dequeue from the front end of the queue. So 300 is the current node and we will print its data. So the data at node 300 is C. So C is printed and this is the current node now. So we will enqueue its left child. So its left child is this node at address 250 and its right child which is at address 350. So 300 has been dequeued. Now again we go back to the loop, beginning of the loop, dequeue and print data. So whatever was there at address 280. So we are now at this level 2 and whatever was the data at address 280, that will be printed D, and its left and right child will be enqueued. So 280 is out but its left and right child, which are 550 and 500, they will be enqueued. So 550 and 500 are enqueued. Now go back to the loop again. Queue is still not empty, so dequeue and print data. At the front of the queue we have node 400. So node 400, the data is E, so that will be printed, and now its children, the children of E, they will be enqueued, but these are empty subtrees, empty left and right subtrees, so nothing will be enqueued. We go back to the checking of the condition, dequeue and print data. 400 was already dequeued. Next is 250. So 250 is dequeued and its data is print F. Now its left and right child would be enqueued. So its left child is at address 480. So that will be enqueued, and right child is null tree, so that is not enqueued. Then we go back to the queue again. So 250 is out. So next in queue is 350. Its data is G. So G will now be printed. It does not have any left and right child. So nothing is enqueued. We go back to the condition again. Queue is still not empty. 350 has been dequeued. Now we are at 550. So 550 will be dequeued and its data will be printed, which is H. It does not have any left or right subchild, so nothing will be enqueued. Now we go to the next node in the queue, which is 500, and prints its data I. It does not have any left and right child, so again nothing is enqueued. Then we go to the next in the queue, which is 480, and we will print its data J. And again, since it does not have any right or left child, nothing will be enqueued. Now when we go back to check the condition, now we see that the queue is empty. So this is the level order traversal, and you can see that at level 0 we had node A, then at level 1 we had B and C, level 2 we had D, E, F and G, and level 3 we had H, I and J. So this is how level order traversal works. So we'll just discuss a very basic pseudocode. So this will be the structure of the node. We are assuming that we are storing character data, and there is going to be a pointer to the left child and a node pointer to the right child. So the level order function, it will accept the root pointer, the pointer to the root as an input parameter. So if it is null, if the root is a null, it is going to return. Then we have to create a queue. We have seen earlier that queue can be created either using arrays or using linked list. So whichever way you wish to create a queue, you can queue. Then we are going to enqueue the root. So the root node, we have the information about the root node through its root pointer, so that we are going to pass into the queue and enqueue it in the front. Until the queue is not empty, we are going to follow this loop over here. First of all, the front of the queue, whatever element is the front of the queue, that will be appointed as the current node, and we are going to print its data. Then if current arrow left, that means the left child of the current node, if it is not null, then we are going to enqueue it. If it is, then we are going to check whether the right child of the node is existing or not. If it is not null, then we are going to enqueue its right child also, and then we will dequeue the current node. That means whatever was at the front of the node, we are going to dequeue it. Then again we are going to check whether the queue was empty or not. Whatever was at the front of the queue, that is going to be the current node. We will print its data, enqueue its left and the right child, and dequeue that element from the front of the queue. So this is how the algorithm for the level order traversal will work.